Hi everyone, this is Manas, your friend and tutor, and guys, in today's session, let's rock this problem. What you see over here is a simply supported beam with a single point load at a distance of 2 meters from the right end, and the stuff that we need to calculate is the slope at this very point, that is a point at a distance of 2 meters from the left end. Okay, isn't this looking simple? Yes, it is. It's a simply supported beam with only one point load. There isn't even a uniformly distributed load. So this looks very simple, but it is not that simple. You will realize that very soon. And some of you guys might be thinking, so we can obviously apply the slope theorem, that is theorem number 1, and get the value of the slope at C. Yes, you can't do that, but that won't be enough. You also need to apply over here the deflection theorem, that is theorem 2, and you will realize that very soon. So just to begin, what we'll try to do is we'll make a hypothetical elastic curve and try to analyze the stuff which has been presented in front of us. Let's begin. Here we go. Just take a look at this. Watch over here, right? Focus on the right portion of your screen. Watch what I'm going to do right now. Let me draw a horizontal line. This represents A and B. The elastic curve, I don't know what the curve's profile is going to be, right? I have absolutely no idea about that. And by the way, I forgot to write this point over here. Let's say this point is D, simply D. Okay, the point where the load is acting, concentrated load of 16 kilonewton is acting. Let's say this is our elastic curve. Okay, let me make the tangent at A. Done. Let me make the tangent at B. Okay, before that, the angle that the tangent at A makes with the positive x-axis, let's say this is the positive x-axis. Let's call that as theta A. It's the absolute angle of tangent A. Simple. Similarly, let's have the tangent from B. This, by the way, is theta B. Somewhere here, what do we have? We have point C, right? From point C, what we'll do is we'll make a tangent. Just take a look over there. Let's make a tangent. Bang! That's the tangent at C. This right over here is point C. Okay? Focus. And one more thing that I'm going to do is this. Can you guys get what I have done right now? Let me make that once again. This is the tangent at C and this is the tangent at A. The angle that the tangent at C makes with A is written as theta C to A. Theta C to A is the angle that the tangent at C makes with the tangent at A. And similarly, there is one more thing which we can do. We can write the absolute angle at C with respect to the horizontal. So what I'll do is I'll make a horizontal from this point, okay? Or you can say a line parallel to this line AB. Let me make that line first. And with respect to this line, the angle made by this tangent C, let's call it as theta C. Let's start mathematics. It's going to be awesome. Watch. This is going to be really awesome. So what you watch over here, this is theta A, and you can say, watch there, theta A can be split up into two parts, theta C plus theta C to A, magnitude wise, not direction wise. I'm talking only in magnitude terms. You can say this. Theta A is a sum of theta C and theta C to A. You can say that. Theta A can be written as, let me write it over here. Theta A can be written as theta C to A plus theta C, isn't it? What we want is this, theta C to A. No. What we want is this theta C. So let us write this theta C as theta A minus theta C to A. Okay. This is the master equation with which we need to be working. Okay. So how to proceed now? Now you know very well what you need to calculate. This is the master equation. In order to get the value of theta C, you need to know what theta A is, you need to know what theta C to A is. But how to approach? Which theorem to apply first? What all values you need to proceed? Let's jump right into that. And for that, we need to do a bit of calculation. Let me tell you what those calculations are. And let me make some space first of all. Okay. Made some space, right? So the beam looks like this. Just take a look. Even if you guys don't know anything about bending moment diagrams, you still be able to work out everything. So this over here is a force of 16 kilonewton. That's point C for you. That's, let's say, point D for you. And that is A, that is B. and let us try to make the bending moment diagram. But before that, you need to know the bending moment values, and even before knowing the bending moment values, what you need to know is the reaction at supports. So we've removed the supports. They can be replaced with these reactions, that is RA for you, and this over here is RB for you. Just take a look. This is very simple. Okay. What we'll do now, take the moment. Take the moment about point A is equal to 0. When you do that, what you have is RB, well, this is 2 meters, this is 4, and that's 2 meters for you. RB, this is RB multiplied by 4 to 6, 6 to is 8. So that's 8 times of RB. Just try to work out the nature this way, anti-clockwise. That's why positive. Then you've got this 4, 16 multiplied by 6. 4 plus 2 is 6. 16 multiplied by 6. Nature clockwise. That's why negative. All of this stuff is going to be equal to 0. It's very simple. RB is going to be equal to 16 into 6 upon 8. So 8 2 is 16, 6 2 is 12. RB's value has been worked out as 12. Similarly, what you can do is summation of all the forces along y direction is equal to 0, and hence you can say that RA plus RB will be equal to RA plus RB will be equal to this downward force, that is 16. Okay, and in that case you can get the value of RA is equal to 16 minus RB, and RB you know is 12. So RA is going to be equal to, well, this is going to be equal to 4 kilonewtons. That's simple. So that was very simple. Calculating the values of RA and RB was very simple. Please take a snapshot because I'm going to rub this thing. Okay, noted? Okay, let me keep it. This is the calculation of reaction. Let's proceed now. Now, let me erase this. Let me erase this also. And let's now use the red color. So, what is the value of reaction at A? That is 4 kilonewton. Brilliant. And this over here has worked out as 12 kilonewton. So, they are balancing that 4 plus 12, that's 16. Fair enough. Now what to do? Okay, we need to also learn how to make the bending moment diagrams. Just take a look. Just take a look. This is going to be brilliant. Okay, let me make the reference line. Reference lines. Here we go. This over here is the positive x, and this over here, let's say, represents the bending moment diagram. Although we are very sure that we need to make the m over ei diagram and not the m diagram. You simply have to divide all the bending moment values by ei to draw the corresponding m over ei diagram. That's very simple. Okay, once you have the moment values at different points, obviously everything else fall in place. Anyway, if you have to do moment calculation, you can clearly see you have a support A, you have support B. So for a simply supported beam, at the supports the bending moment is 0. You just need to work out the moment at C, you just need to work out the moment at D. Okay, how to do that? Let us proceed now. Although let me tell you very frankly, if you are into moment area method, then you should know all of these things. Still, for this particular problem, let's do it in a wholesome manner. Okay, let's say we want the bending moment at C. What is the bending moment at C? How can this be worked out? Let me just show that to you. It's going to be very, very simple. Let us do this in blue. Here we go. You want the bending moment at C. So the bending moment at C can be found out using this portion of the beam towards the left of C you can say, and it can also be worked out using portion of the beam to the right of C. Let's say we want to work out C by considering the portion of the beam to the left of C. So it's something like this. That's point C for you, that is load for you, that is 4 kilonewton, and this distance, you know, this is 2 meters. So if you want the bending moment at C, just try to work out the nature. Bending moment at C is equal to obviously 4 multiplied by 2, and this is going to give you the value as 8 kilonewton meter. Very simple, very simple. And it is going to bend the beam in this fashion, isn't it? What is this? It is a clear-cut case of sagging. If it is sagging, then it's a positive bending moment. Very easy. Now some of you guys might be thinking, so can we do the same, or can we get the same value by considering the portion of the beam to the right of C? Yes, you can do that. Let me just show that to you. Right of C. It's going to be awesome. So we are going to be considering the portion of beam towards the right of C. Here it is, slightly bigger. Okay. Right of C. So this is C. So this is point D. Load is 16 kN, and this over here is the reaction at B. How much is it? That's 12. Okay, we can do that. So again, it's going to be fairly simple. This is 4 meters and this is 2 meters. What do you want? You want C, moment at C. Let us start from this point. 12 multiplied by 6. So if you want the value 12 multiplied by 6, right? Because of this, and it will tend to bend the beam in this fashion, isn't it? It's a sagging case, therefore positive. What about this? 16 multiplied by 4. So let me just write 16 multiplied by 4, and now think about the nature. It will bend the beam in this fashion. What is this? This is the hogging case. That's why a negative sign. 12 6 is 72 minus 16 4 is 64. 72 minus 64, again you'll get the same value, that is 8 kilonewton. Damn simple. So simple, isn't it? Here, let me mark it. So we got the value as 8 kNm. Brilliant. Right? Please note these things down. If you don't want to, don't take a screenshot. If you want to note, take a screenshot. Pause the video and take a screenshot. Let's proceed. Okay. And if you want to get an in-depth knowledge of shear forces and bending moment diagrams, you should watch my videos on that very topic. The links to which can be accessed from the description down below. Each and every topic has been dealt in depth. पूरा धागा खोल के रख दिया उसमें. उस वीडियो को देखिए. Do watch it. Do watch it. Now, let's find the moment at point D. How can we do that? Well, I'll consider only the portion of the beam towards the right of D, because that looks very simple. So towards the right of V, we've got this point. What is this? This is 12, right? Where do you need to find the moment? You need to find the moment at D. It's very simple. 12 multiplied by, this is 2 meters. 2 meters, this is going to be 24 kNm. It's that simple. If you don't believe me, you can take this portion also. Left, this is how much? That is 4 kN. And this is point C, guys. And this distance is 2. And what about this? This is 4 meters. Okay. Any other load that we have? Yeah, that's it. Simple. Again, if you watch, this force will tend to bend the beam in this fashion. Again, it's a case of sagging. So bending moment at point D is equal to 4 multiplied by 4 plus 2 is 6. 4 into 6 is same 24. Here also, this will tend to bend the beam in this fashion. That's why positive. Now you know. Okay. This will work out as 24 kNm. Now, this is how the bending moment diagram would look. That's it. Now we can proceed over to the next slide. Okay. Please note down these values. Bending moment at C is 8. Remember, C is 8, D is 24. C is 8, D is 24. Let's work it out now. Let me rub all of this. If you want to note it down, pause and note. Let's go ahead. Just take a look at this. Beam, right? M over EI diagram. Okay. This is the M over EI diagram, not the bending moment diagram. So, but they are going to be same, because every bending moment value has to be divided by EI. It's that simple. Anyway, just take a look at this. A, this is for C, that's point D. I forgot to write it down. Sorry. Okay. So the value of bending moment that we got at C was 8. So since this is not the bending moment diagram, this is bending moment divided by EI diagram. So all the bending moment values have to be divided by EI. 8 divided by EI will give you this corresponding value, right? Similarly, here at point D, we got the value as 24. So 24 divided by EI, as this is the M over EI diagram, and here it is. Let me show you. Join, join. And this is the area that represents the area under M over EI diagram between points A and point B. Here it is. Now what to do? So you have this. Okay, so I forgot to here mention I forgot to mention something. Let me just see that. Okay, I forgot to mention the values of Young's modulus as well as moment of inertia. Don't worry, we can access it from this slide also. Okay, we have it here, not to worry. Okay, let's do this again. Let's go back. So these were all the tangents. Tangent at C, theta C to A, and this was theta C. How can we proceed now? How can we proceed? We have the bending moment values, we have the bending moment diagram, we have the M over EI diagram also now. It's only a matter of applying all the theorems, not all the theorems, there are only 2 theorems that you need to be bothered about, and let's apply them. First of all, let us try to work out. Where is my blue pen? Here it is. Here it is. Let's get theta A. Let's get theta A. Okay. How can theta A be calculated? It's going to be very simple. Guys, you need to watch. You need to watch right here. Focus. Just see what I do. I've extended this tangent. Okay. Just extend it up to any length. And now drop a line. Drop a vertical line from B. Drop a vertical line from B. Just like this. And they're going to meet somewhere. Obviously, you can clearly see that this over here represents a right angle triangle, isn't it? This represents a right angle triangle. And whenever you see a right angle triangle, don't worry, simply apply trigonometry. Let me tell you what I'm going to do. I'll write over here tan theta A. What is tan theta A? Tan theta A is equal to this perpendicular, that is TB by A. Okay. I'll explain what TB by A is. This is TB over A whole divided by base. How much is the base? 2 plus 4 plus 2, that is 8. Simple. Again, to find theta C, you need to find theta A as well as theta C to A. To find theta A, you need to find these two. Now, again, this elastic curve, as I told you, this is an exaggerated form. Originally, no beam deflect in this manner. The angles of deflection, the slopes at these very points, right, at the end points, that is at A and B, the slopes are extremely small, extremely small, right? So when the angle is very small, when theta is very small, then in that case tan theta can be assumed as theta. So what we can write over here finally is that theta A is equal to TB over A divided by 8. Now some of you guys might be thinking as to, sir, what the hell is TB over A? Don't worry. Once again, let me show that to you. Tangent at A and this is tangent at B, right? Tangent at B and this is tangent at A. The vertical displacement of the tangent at B with respect to tangent at A. Once again, listen to this very carefully. Don't watch me. Watch the animation right here. The vertical displacement of the tangent at B, that is this, with respect to the tangent at A is written as or is read as TB to A. TB to A. B with respect to A, you can say this. So this is going to be our master equation. What we need is simply we need this value TB to A. And now the task is going to be a bit simpler, and you guys must have read theorem number 2, and if you haven't, go back and watch my videos 11, 12 and 13 or 14, I don't know. Watch the previous videos to know more about how to apply theorem number 2, that is, well, popularly known as the deflection theorem. Anyway, let's do this. And by the way, happy Raksha Bandhan to everyone and happy Independence Day. Now that's TB to A and that's 8. How to proceed now? Theorem number 2, what does that say? Vertical displacement of the tangent at B with respect to tangent at A is equal to the moment of the area under M over EI diagram between points A and B. Let me just write that for you. TB to A is equal to moment of the area under M over EI diagram between points A and B. But how to apply this? Let's see that, and it's there in the next slide. Let me show that to you. Okay. So let me rub this first of all. Here we go. Just watch. This is something which we have already made. Here we go. That's it. 8 over EI. Here the bending moment was 8. So divide by EI for the corresponding value in M over EI diagram. And that's 24. There you go. Done. And that's the shaded region. Right. This is the total area between point A and B. Moment of area of M over EI diagram between points A and B. How can you find the moment of area? Well, it's going to be very simple. A bit of construction needed. Watch. What is this? Just a reference line. Now you have to, what you need to do is you need to find the moment of area. But remember this, since you have to finding the deflection at B, what you need to do is all the moments have to be taken with respect to point B. Okay, whichever it is written first over here, with respect to that point, we need to find the moment of the corresponding area. So here we go. Watch this. Right over there. Okay, focus on the screen, right part of the screen. Division. So there are essentially two areas, ADD dash and BDD dash. Right? So let me have the centroids also. So this ADD dash area will have its own centroid at this point, that is GADD dash, and this portion over here, this smaller right angle triangle. Okay, first of all, let me just write this. Moment of areas, right? TB2A. So moment of area, what is that? That essentially is x bar multiplied by that area. That is the moment of area. And how can we write this essentially? Just a second. Let me see if the recording is still on or not. Yes, it is on. So watch this. Let us take a look at this area first. ADD dash. The moment of this area is going to be this area itself multiplied by the distance of its centroid, that is this point from this point B. This is the distance that we are looking forward to. Anyway, so this can essentially be written as, let me watch, area what? Not just any area, ADD dash multiplied by centroid, and its distance has to be measured. GADD dash has to be measured from this dashed line you can see. Okay, this GADD dash. ADD dash, let's go forward. Then we have got another area to deal with, and this is DBD dash. So that's area DBD, क्या था? BDD dash. Fine. This is BDD dash and dot. Again a centroid over here. Okay. Its centroid is going to be somewhere here. Let me just show that to you. Right. The centroid is right here. That is BDD dash. BDD dash. Now let us get the values. Fairly simple. Fairly easy. Watch this. Let us get back. So let us first of all talk about the distance of this centroid of this area at ADD dash from this end B. Okay, for any right angle triangle, remember this, for any right angle triangle, like this, let's say, if this is B, if this is H, this is centroid, this over here, this x bar is equal to B by 3. Okay, always from the right angle, the distance of the centroid G is always B by 3. That is the same philosophy with which we will be working. If the triangle is like this, then again it's going to be very simple. If this is B, this is H, centroid from the right angle, this x bar will be equal to again B by 3. So now you know this. Now in the previous video I have explained all the centroids and area calculation of parabola, x parabola, right angle triangle, scalene triangle. All of that has already been dealt. Okay, so there you go, it's B by 3. Now if you watch, if I ask you this distance from A to D, it is 4 plus 2, 2 plus 4, that is 6. So this is 6. Just focus on this triangle ADD dash. Okay, this is 6 divided by 3, this will give you 6 by 3 is 2, and we want value from this end over here. So this distance we already know, that is 2. 2 plus 2 is going to give you 4. That's it. Now you know. So let us plug in the values. So this area ADD dash, half of base into height. Base is 6, height is 24 by EI. So this is going to be, area is half of base is 6 multiplied by height is 24 upon EI. And when you speak about this centroid, you also know that the distance of this centroid from this end B is 4. So just multiply it by 4 and we are good to go. Plus again an area. Now we need to know what the area A, not A, but BDD dash is. So this is half of base, that is 2, height is 24 upon EI. Base is 2, height is 24 upon EI. Done. Multiplied by this location of its centroid. Watch. Again, B by 3, same concept. The centroid is going to be somewhere here. Okay. So this distance, we know, if this is 2, if the base is 2, B by 3, this is going to be 2 by 3. Then this stuff over here, this much remaining distances can be calculated by 2 minus 2 by 3, which is equal to 4 by 3. And that's done. Isn't this simple? You won't believe, making this animation took me almost 2 hours. Okay. It really takes a lot of effort to make quality stuff. Really it is. Anyway, you just need to go through this calculation and everything will be sorted. So 2 and 2 will be cancelled out. 3 times of 8 is 24 and 2 times of 2 is 4. So just a bit of mathematics. Where is my calculator? What is supposed to be done? 6 2 is 12. 12 into 24. So 12 multiplied by 24 will give you 288. So this is working out as 288 over EI. What else? Plus this over here. So 8 4 is 32. No. 8 4 is 32 and that's done. Okay, this 2 has also been cancelled. 2 and 2 will cancel out. 3 8 is 24. 8 4 is 32. So that's 32 over EI. And this is working out as, let me write the final value. And this theta A, guys, theta A. Not theta A, but this is TB2A. Correction. TB2A has worked out as, well, 288 में 2 जोड़ो ये हो गया 290, 290 में 30 जोड़ो 30 हो गया 320, 320 over EI. Brilliant. And by the way, the unit over here, the unit, let me just write this in the numerator, is nothing but kilonewton meter square. The unit over here is kilonewton meter square. Remember this, okay? Because initially the value of bending moment that we got was 8. Force multiplied by displacement, okay, or distance, let's say. So that was in kilonewton meter. And when you divide that by EI, and E and I have their separate units. We will deal with that later on when we plug in all the values finally, right? Let's proceed now. So we know very well what the value of TB2A is. And if you know the value of TB2A, you can obviously get the value of theta A, and theta A is equal to this 320 over EI, that is TB2A whole divided by 8. And let me write the final stuff. Theta A is equal to art chalk, but this 40 over EI, that's 40 over EI. Done. Theta A conquered. Okay. Theta A conquered. Now all you need to worry about is the calculation of theta C2A. Again, can be done very easily using the slope theorem, that is theorem number 1. Very, very easy. So, क्या करें? Let's do this. Okay. Now we need to calculate theta C2A, right? Let me write it here. Theta C2A. So just try to recall what theorem 1 says. What theorem 1 says? Should we get back? Should we get back to the previous slide? Let us get those values once again. Okay. The angle that the tangent at C, okay, makes with respect to A. what are we calculating? Not theta c, but theta c2a. Okay, we are calculating this theta c2a, theta c2a. The angle that the tangent at C makes with respect to A equals the area under M over EI diagram. Once again, the angle that the tangent at C makes with respect to A equals the area under M over EI diagram between those same points, that is A and C. Let us write this statement first. Right? So my only wish is to calculate the area between A and C from the M over EI diagram. And now let's get back to business. Okay, so if you watch between A and C, this is the area I'm talking about. This is the area I'm talking about. Watch the cursor. This is the area A C dash C. So essentially we have to calculate this theta C to A. Let me write this once again, is equal to area, not just any area. What is the name of this area? If I can just draw this C dash and C, if I can just connect this C dash and C, there is going to be a right angle triangle A C C dash. This is going to be A C C dash. You just need to find this area and that's it. You've got the slope of tangent at C with respect to A. So if you watch this from A to C, the distance is 2, the height is 8 over EI. It's very simple, very basic. Half of base into height. Just do this. Half of base. Base is how much? That is 2. Height, guys, is 8 over EI, and that's very, very simple. It's very, very basic. And this is working out as 8 over EI. Just let me make a very quick check. This is working out as 8 over EI. So both the thetas have been conquered now. Both of them have been conquered. Let me just write this finally. Theta C to A is equal to 8 over EI. Again, let me repeat, this also is in kilonewton meter square. You've got to be very careful about the units, because finally we'll be plugging in all the values and we'll be calculating this value of theta C in radians. So I hope all of this is clear. So if you want to note this down, do pause the video and do note it. Let me get away from the screen. Looking brilliant, isn't it? So let us apply the finishing move now. Let me put in the values of theta A and theta C to A, theta A and theta C to A from these two fellows out there in this equation, and let us finally get the value. Let us get this done. Here we go. Again, let me make some space. Here it is. What do we want? We want theta C. What is it equal to? Theta C is equal to theta A minus theta C to A. How much is theta A? Well, I calculated it somewhere. That is 40 over EI. Okay. This is 40 over EI. Minus theta C to A, that is 8 over EI. This is very simple. Very simple. Baby mathematics. 40 minus 8. If we take the LCM, it's EI. 40 minus 8 is 32. So finally, theta C is equal to 32 over EI. Again, remember the unit that 32 represents is kilonewton meter square. That's theta C for you. One more thing. Let me just refer my notes. See this? I actually do this initially before making this video, right? So that I remember everything. Anyway, the value of E has been given to us. The value of E was given to us, isn't it? Let me go back to slide number 17, and this value has been given to us. E is 200 GPa and I is 17 into 10 raised to 6 mm power 4. Okay, so let me write this. E is equal to 200 GPa. Now remember guys, this value has been computed in kilonewton meter square. Why? Because the point load that was given to us was in kilonewton, 16 kilonewton, remember? Right? So can we convert this also into kilonewton meter square? And by the way, this Pascal is Newton per meter square. Don't panic. 200 into 10 raised to 9. 200, 10 raised to 6, 10 raised to 3 pascals. So what I'm basically doing is that I'm going to be converting this gigapascals into kilopascals. So this is essentially 200 into 10 raised to 6 kilopascals. Done. So E has been converted from this to this. Secondly, what we can do is we can convert the value of I also. Moment of inertia, area moment of inertia, by the way. This has been given as 17 into 10 raised to 6 mm power 4. 17 into 10 raised to 6 mm power 4. Guys, you should know this. This this m over here is representing milli, and this m is representing meter. So when you speak of milli, it is 10 raised to minus 3. When you talk about micro, it is 10 raised to minus 6. When you talk about nano, it is 10 raised to minus 9. Then you have got pico, femto. Okay, so this can essentially be written as 17 into 10 raised to 6. Milli can be replaced by 10 raised to minus 3, and this is meter power 4. Same stuff, 10 to the power minus, let me write this, 17 into 10 raised to 6 into 10 raised to minus 3 into 4 is minus 12, and this is going to be meter power 4. So everything has been converted into kilonewtons and meter, right? So just do the math. This is going to be fairly simple. 17 into minus 12 plus 6, 10 raised to minus 6, and that's meter power 4. So again we have this value converted. You just need to plug in all these values into this equation to get the final value of theta c in radians. Let me show that to you. Theta c is equal to, this by the way is 32, well the unit is kilo Newton meter square, and this divided by, denominator is going to be pretty long, 200 into 10 raised to 6. 200 into 10 raised to 6, the unit is, let me check, kPa, don't worry, Pa is Newton per meter square, right, kilopascals. And then apart from that, we've got this 17 into 10 raised to minus 6 into 17 into 10 raised to minus 6, and this is, unit is meter power 4. Do make a check also, right? Everything is perfect. When you plug in all these values in a calculator, you are going to get a final value of theta c in radians. Let me make that claim again. You are going to get the value in radians, and that will finally work out as 0.00941. 0.00941. Not just any angle. This has been worked out in radians. Okay. The video has become a bit too long, but what to do? Some problems deserve some respect, deserve some attention, deserve some time, and also your patience. So guys, note this down, pause the video, note this down, and that was all for today. I'm going to see you again in the next video. Until then, take care, have a nice day, keep learning, keep watching. Jai Hind, Jai Bharat, and happy Independence Day to all of you. I know कि ये वीडियो कल अपलोड होगा and tomorrow is going to be 16th of August, but not to worry. ठीक है, we are all Indians and happy Independence Day. Thanks for watching today's video. Take care.